What's up, guys? Chris with CNC for Newbies here, doing coffee and cuts in the morning, episode 2 on the reboot. Um, Wanted to go live and talk to you guys about um, some advantages of different control systems. So, uh, as a lot of people get into this, they they deal with um, a control system called GRBL, firmware called GRBL, and it operates on a Arduino Uno, Arduino Nano, or Arduino Mega. There's a couple other different firmwares, um, but basically our Arduino uses um, GRBL, and that will control a CNC router, CNC mill, CNC lathe, and a CNC laser, diode lasers, CO2 lasers. So with that, you end up with um, something that is open source and available to the public, um, very inexpensive to get into, but it doesn't necessarily operate the best because it's open source and there's so many different components of it. For me, this is just my opinion. GRBL is best suited for diode lasers on a CNC frame. Okay, that is just my opinion, and um, my preference is to utilize a good driver system and UCCNC. Um, I have here, this is a C4N Pro controller um, from CNC for Newbies. The core of it is a Gecko G540, and this is kind of a bulletproof solution for driver control. Okay, um, it uses a DB25, which is parallel port, the old printer port systems and stuff like that. Um, but it has 4 drivers built into it, and all the guesswork is kind of taken out of the wiring, other than plugging in your accessories like um, you've got limit switches, you've got touch probe, you've got e-stop, you've got PWM control, and then power to the Gecko itself. Um, this is a great solution, but you cannot use the GRBL software on it. So what we use on it is either Mach 3, UCCNC. There are a couple kind of no-name systems that you can use on it. I shouldn't say no-name, but different systems that you can use on it. My preference for that is the UCCNC. You use either the UC100, you use the UC300, the UC400. Okay, most people are going to use the UC100. What's nice about this is these are bulletproof stepper drivers. The DB25 plugs right in, or your DB25 converter plugs right in. Okay. The downfall to it is it uses an analog converter for your PWM. So it works, it doesn't work. Every system needs set up differently. Okay. Whereas GRBL, once you have it set, you have it set. And what's nice about GRBL is it uses digital PWM outputs. So the UCCNC I love for the router use, and especially with B&R's new VFD kit using the RS485, it's pretty much plug and play with a VFD and then all of the ancillaries that you would want on a CNC router. Okay, and I really love that part of it. The downfall is it's kind of cumbersome to use a diode laser. You have to dither the image, which means you have to turn it into small pixels, and they have to be solid black and white. The grayscale, it's hard to get it to do grayscale because for laser switching, it's a much slower process. I have to preface this with these are my opinions. After using a multitude of different controls, different softwares and stuff, these are my opinions. So a company came up with a solution that was pretty ingenious. I love the way that they implemented it, but we have Viking CNC Controls came up with this little dongle, and this little dongle allows you to convert from a GRBL system into the Gecko drivers without a lot of fuss. Basically, you set up your GRBL firmware on this. Inside of here is an Arduino Nano and a DB25 connector, some other stuff. And for the Gecko, let's see here, feed that way, then those will tighten in. Okay, so the Gecko is assembled, on your machine and everything. This simply plugs in, let's see, as such, and then off of this, you have direct digital PWM control for a diode laser, like a JTEC. You guys know I love my JTEC lasers. Other companies such as Endurance, Opt, NEJE, El Cheapo, stuff like that. Those lasers run on this converter much better, in my opinion. And they allow you to use a software called Lightburn. And Lightburn is kind of the mainstay across the diode laser setups. That's kind of par for the course. Whenever you get a laser, everybody recommends Lightburn, and you run it that way. What this converter really allows is the use of the grayscale PWM output for transitioning the laser power into a grayscale image lasering. So it switches very fast. The laser no longer gets fed through the Gecko. It now gets fed through the converter and uses the digital signal. And to me, I love that part of it. And once again, this is just me talking. These are my opinions, but the combination of this Gecko G540 with the GRBL control software is probably one of the best things for the diode lasers, because you're not going to get a lot of overheating issues. You're able to get micro stepping. You're able to do a lot more stuff with this combination at a faster pace, so to speak. And all of this, once again, this is a very broad topic. We're going to have guys hop in and say, oh, it depends on your motor size. Oh, it depends on your drive transmission system. Oh, it depends on your computer. Oh, it depends on this software and that software, so on and so forth. All of that stuff is very important, but as a superficial conversation, running the diode lasers on a Gecko G540 has really never been a simple task. And with that task, we have now taken and gotten the Viking CNC controls converter to plug right in. So you can go from your UC100 running the router VFD optimally, right? Because UCCNC, in my opinion, is better for the routering, to now running the laser off of this. And if you really wanted to trick out your system, you could run this with the UC100 on a DB25 AB switch. You just switch between those with an AB switcher. You can get them on Amazon uh, and stuff like that. But that will allow you to have one input into the Gecko, and then you just flip a knob, and you're ready to always have this hooked up with your UC100 and switch in between routering and lasering very quick and easy. Then you get all the benefits of the digital PWM versus the analog converter PWM. It allows you to power the laser off and on just like you were using a generalized GRBL system. Then you switch over to UCCNC and you can use the VFD router system, especially with the RS485 setup. Um, that's that's like the best thing that you can have, in my opinion. Um, the RS485 for the VFD is akin to having the digital PWM for the laser. Okay, it is set up on a frequency system. It has a 10-spot frequency cable and registers that. Actually, it might be a 20-spot, but anyways, you put that in and it goes from there. Um, with everything set up the way that it's set up, with those two USB systems, you can go into a DB25 real simple. You have a kind of bulletproof starter set with the stepper drivers and everything. And then from there, you could start upgrading to a specialized control system um, for maybe hybrid steppers where you do a feedback encoder loop in the driver and stuff like that. Uh, it's one of those really. It's just a really cool setup. So let's pull up the two systems here and see kind of what we're dealing with. We'll pull up Lightburn. Now this was given to me by Jay over at JTech, and I didn't use it too often because I don't do a lot of picturing anymore. So what okay. Oh, I upgraded and I didn't put in my license. Okay. Well, maybe I won't. I didn't upgrade my license in Lightburn yet. All right, let's start UCCNC and continue. I do have this in demo mode because I don't have my UC100 or my UC300 hooked up to it. But let's see if we can organize this cluster of stuff. Okay. Now let's share screen. Okay, so this is UCCNC. It's a great interface. I was playing around with some of the colors and stuff, trying to make a screen set for CNC for newbies. Um, but um, we have a bunch of stuff here, and then on top of that, hey Seth, what's going on, my man? Um, we're gonna stop sharing, and then we're gonna share another screen, and this one is the uh, the RS485. Sorry about that being in the mic. Uh, but this will give you the RS485 connection to the VFD, and that will send out a digital PWM signal, and then it references a table, a frequency table, um, and it works out really nice for the VFD. So basically, we're doing the same thing with this converter as we're doing with the RS485. Basically, don't jump on my butt because this, that, and the other. But one of the systems we can use, uh, there it is, Pick and Grave. Okay, let's see here. Trying to set these windows up so I can still see everything. Let's see. I got to be able to see my comments coming in. All right. Okay. Seth says, "Hey, how's the weather?" The weather is great here, even though it's cold. Cold is like 66 degrees this morning. You have to go into the house to warm up. So, with that being said, let's select an image and let's share. Okay, so this would be a GRBL style G-code producer. It's called PickSender. It's our Pick and Grave. It's from the guys at pickandgrave.com. It started out as Jeff Woodcock and John Chaplin. Now it is Jeff Woodcock Jr., I believe, is the owner. So on and so forth. But anyways, you would generate a G-code file that references a scale of power for the laser. There would be 255 different frequencies. That frequency would generate into the 256 different colors in the grayscale, and you would adjust everything. Let's see here. So these are all the settings you could adjust, and once you adjusted them, you would load the image. You would generate the G code. And now we save the G code. all this happens. So what's happening is it's taking all the different colors, it's converting it to a grayscale image, and then it's assigning a PWM signal between 0 and 256 to the grayscale colors. That then will run through this little converter, and the PWM signal will be sent from this little Phoenix connector to the laser, rather than having to run through an analog converter and then back into something that would be kind of converted for no reason. Um, so that's how the converter works, and that's how it would be beneficial to have the converter with the UC100. You use the proper softwares with them, and to me, that combination gives you the best setup for grayscale images on a diode laser on a CNC router, and then you can also um, use the UC100 for the router and VFD. So that to me is the best setup when it comes to utilizing your machine as two different um, two different types of machining. One's laser, one's uh, router. You know, so that's that. Yeah, you're missing all the fun here. Good to see you back, man. Hope everyone is doing well. Everyone's doing good. We're trying to get everything squared away. I'm actually leaving on a plane. I'll be doing coffee and cuts tomorrow from Colorado, so that'll be kind of interesting. Um, and I gotta teach a class in Colorado at a furniture factory, where I'll be teaching them to use UCCNC Mach 3 and Aspire to create 3D carves for their custom furniture that they're doing. It's kind of cool because they're actually in a Aspire system, but it's Aspire 4. So that'll be the oldest Aspire that I've actually been able to see and play with. Um, so it'll be kind of cool. But the machines are, once you know one machine, you basically know all of them. It's just a matter of familiarizing yourself with the uh, assembly systems and the add-ons, the limit switches if it has it, and stuff like that. So, but guys, we've got some viewers in here. Let's get some questions. Any questions on how the converter works with the Gecko? Any questions on why one's better than the other? Um, in terms of what they promote you doing. Um, One caveat I should say is you can actually run your whole system on this converter. This is an Arduino inside of here, so you could load GRBL on this and plug it in here, and you have a kind of a bulletproof controller right here. You add a power pack to it, and you're good to go. You can control your limit switches, you can control your steppers, um, you have your PWM signal, and you have the resume, pause, abort buttons that are normally found with GRBL systems, all right here. So for you guys that want kind of a plug and play system for your homemade routers and stuff, and you want to have nice high powered, high voltage, high amperage stepper drivers and bigger steppers, this right here is a full solution. You know, right there. That's it. Um, you know, that that allows you to run Gerbil. So if you have, say, pick sender, which is a Gerbil sender, or UGS as a Gerbil sender, those are G code senders. Um, you can come out of uh, vCarve or Aspire with the Gerbil G code, and it'll parse it right through this. So your VFD signal or your IoT relay signal will come right out of this PWM, just like if you had, say, uh, Phil Johnson's Demon controller, um, the uh, uh, the X controller, um, the the Uno Shield, and stuff like that. Uh, all of those you utilize an Arduino Uno. Uh, this utilizes an Arduino Nano, which is of the same sort. It's the same family of controllers, um, just in a smaller format. So you could actually use this assembly right here and utilize it on your open source uh, homemade CNC, or you could convert your CNC to an Arduino Gerbil system with this. So it's actually a versatile setup. And the fact that it allows you to use kind of an industrial style stepper driver box is amazing. Um, you could also utilize a breakout board system, and have even bigger drivers with the feedback loop, and everything like that for encoders, and put your own system together. CNC for Newbies has a breakout board system with the 5 drivers, so you can actually have 4 axis. You have 3 axis with the slave for the machine, and then you have a rotary axis. That operates great on UCCNC, Mach 3, stuff like that. But the Gerbil implementation of that makes it much more difficult to do the rotary axis. Okay. Can it be done? Absolutely. Is it fast and efficient? No. It's cumbersome. It's kind of just hard to implement correctly. But uh, with the UC setup, that allows you to have your tool changer, your touch probe, your tool setter probe, um, um, VFD. It has the gambit of all the good stuff for the router. Um, and then you want to use the laser, the converter makes it nice. So that's why I like having those 2 dongles that plug into the Gecko. You know, um, the big thing is a lot of people mistake this as the controller. This is not the controller. These dongles are the controllers. They hold the firmware that tells the machine what to do. Okay. Um, Once you plug these into the driver board, now you have a full controller that the controller can control the drivers control the motors. So this tells the drivers what to do, the drivers tell the motors what to do, the motors move the gantry and the tool, whether it be a spindle router or a laser. Okay, so make sure you have those distinctions as to what kind of controller you're using and what kind of um, driver setup you're using. This is nothing more than a 4-axis driver board. If it was plugged into a DB25 parallel port, like the old printer ports, from the 80s, 90s, and early 2000. Um, this is still just a driver board. The computer is the controller. Okay, the sending computer is the controller. It's controlled through the parallel port card. Um, this is a controller. Okay, the UC100, 300, or 400 is the controller. That's what holds the firmware and sends out the signals that the drivers need. Okay, so just be fully aware of the way that that happens and what's going on with it and everything like that, and understand that like this in combination with this gives you a great bulletproof starter set for a router, but its real merits come when you can combine this with this and a diode laser and say Lightburn software. Now you've got something that's been, the firmware's been optimized for laser. You've got a great driver board, and you're ready to go. So I think that's going to be today's showing. Why don't we put a pin in this and we will go from there, and I'll open the table up to questions. So we've got a few people in here watching. Um, I'd like to get questions from you guys. I want to get this back where we're able to kind of show people the the merits of CNC and get people rocking and rolling on a CNC. Um, um, yep, we've got a couple people watching on different platforms. We've got Seth on YouTube. We've got a few people watching from Facebook. Let's see. We've got a few watching from the different groups. So come on, guys, shoot over some questions that you might have. I didn't explain it that good. Seth says, "Hell yeah, keep hustling and inspiring other creative minds." Seth, thank you so much. That's what this is about: is inspiring others and making sure people know what kind of stuff is out there. It's not the end all be all. A lot of stuff is very topical conversation, just because of the way that CNC is in the CNC industry. Things are changing every day. I mean, we have Acorn systems from Centroid. We have Maso from I don't even know who makes that. We have Fanuc controls. We have specialized controls. We have guys writing controls in Python. We have CNC Planet. We have Path Pilot. We have all of these different senders and interface programs and stuff like that. You guys have no idea the amount of resources that are there for you to start doing this in your garage. You can literally start your own side hustle utilizing CNC machines for nothing. Like cobbling stuff together. And I say nothing, it does cost you stuff. But if you have the right connections and you have the right people, you're good to go. Oh, we got two commenters popping in. Good morning, cuz listening and TIG welding some parts up in the shop. See, and that's what I'm talking about. Uh, my cousin Kevin's a TIG welder by trade, or a welder by trade. He does a lot of TIG welding and stuff like that. You know, the ability for him to actually attach a MIG welding gun to a robotic arm that he built himself is a very real happening now. This is something completely different than what used to be. Used to be only big factories had this. Only multi-million dollar companies, you know, publicly traded or private uh, government agency companies, um, private government contractors, stuff like that. Only they had access to the stuff that we're now talking about, like the implementation of, if you want to do this, you go on YouTube, you learn how to do it. You go on YouTube, you learn how to build it. You go on YouTube, you learn how to actually implement the whole assembly, and then you go on YouTube and you learn how to run a business, and you make a business out of it. I mean, and legitimately, this is on the higher end of cost, but you're looking at $279 MSRP. I think you're looking at $140 MSRP. Don't quote me on that. I'm not sure. Um, I do have to let you know that this was given to me by the company, um, mainly just to actually stress test. You know, I'm lucky enough that companies send me stuff to break. They're like, find the weak points in what we make. um, that's Seth says, I'm stuck in the Iron Age. I really don't have any relevant questions. Um, Actually, Seth, uh, the Seth is a blacksmith by trade. We've had him on here, KS Ironworks, um, and Seth has a really unique system where you could forge a blank that I might need to machine, whether it be aluminum or steel or copper or brass, you know, whatever the case may be. Um, you know, uh, you have the ability um, to make the blanks that I need to machine. So you're a part of it. A lot of people need to understand that your uh, technical expertise is where my technical expertise intersected, um, because we need guys like you that understand how metallurgy works, and hey, if I have a big enough hammer, I can smack a piece of iron into the shape that I need it, you know. And you have to have a hard hammer, and you have to have a soft touch. So don't ever sell yourself short, because ironworking is the is kind of the beginning of the process for everything that I do. That harkens back to the times when we didn't have machines. Uh, there were guys that had to sit there and peen rivet bomber seats for for the uh, for the planes and stuff. You know, aircraft carriers used to have milling machines and lathe machines on there, and you had a guy that was able to do this stuff manually. Now we have guys that are telling computers to turn motors like a guy used to turn hand cranks. That's all. That's all. Um, you know, we have robotic arms that can take the ingots right out of the forge on a path. They move it over to the hammer, um, you know, a Yoder style hammer or whatever it might be, and um, it'll smack it into the design that you need. Um, then that's just another way that technology and personal thought and creative solutions come together as one whole assembly. You know, Seth, you form the ingots or the forges or whatever that I need, the parts that I need. I machine them into spec that Kevin needs, and then Kevin can weld them, or he can program a robotic welder. And now I have a full supply chain, and at the end of it, with the implementation of these machines, a we have a system that we have employees that are 365 day a year, no vacation, no sick time, no benefits requiring employees. That's what it amounts to. Um, and there's a weird dichotomy there because you have you have the people that are saying, "Oh, you're the reason why uh, Americans or the world are losing jobs." Really? I'm developing technologies to make a product less expensive for the end user or the maker or whatever the case may be. I come up with creative solutions. Am I really the problem, or am I the next step in innovation? Uh, as the guys that used to tinker with their cars in the garage, and then they realized that they needed a machine, and then they're like, "Oh, I've got this part that I want to make." That's kind of the progression to me, and it all starts with something. And I say this without being derogatory. It starts with something as stupid as a converter and a driver box. Boom. That's all you need. Um, you guys really want to learn some stuff. We've got my friend Beaker is teaching at the Rochester Technical Institute. We've got um, we've got Titan over at Titans of CNC Academy, teaching free of charge how to not only design the parts in CAD, not only write the toolpaths in CAM, but then also how to set up the machines. And he's showing you so many different machines that you'll probably never ever put your hands on. That it's really cool to see. And he's doing the same thing on a much bigger industrial scale because he's taking like Kennametal tools and Mighty Bite clamps and all of these big names, and he's doing the stress testing on a large scale. So that to me, that's kind of the pinnacle. Like right now, I'm bitching because I need a CNC mill. I had to give up a lot of my CNCs when I moved to Miami, and now I'm in a position where I need a CNC mill, and I'm like, well, damn. Now I got to figure out how to finance a mill and everything like this. Um, you know, and Titan is sitting there like, yo, we're pushing these mills to the max. This is what you can do with it. I don't recommend it, but it's capable. So now I can sit there and look at like a Tormach mill, and Titan is pushing that thing with a Kennametal bit, and I'm like, oh, so that's what I can do with it. And a lot of the stress testing is already done when you look at that. And at the heart of it is a controller, a computer G code sender program, um, you know, uh, the controller firmware, and then your drivers and motors. That's it. So let's see. Kevin, I've done a lot of plasma cutting by hand over the years and still do, but slowly having to convert over to plasma cutting machines and working with a robotic welder now. This info is really helpful when it comes down to the technology side of it. Kevin, man, that's progression. You're not stuck um, just knowing the different um, techniques for welding. You're actually learning. Um, you're actually learning new skills to make your welds better. Um, and that's huge because that's the next progression of hey, I'm able to do this, so you're more valuable to your company or to other companies um, when you learn that stuff. uh, CNC plasma cutting is an art and a science. um, and a lot of it starts with this stuff right here. So when you get down to the nuts and bolts of things, you know, you can dismantle a DVD player, and you can make a small format driver and not driver, small format CNC drawer, um, and that will allow you to implement these. And then once you implement those, you draw small little index card drawings, or maybe you use it to make a small little computer chip, stuff like that. It all has to start somewhere, and that's kind of where everything is headed. And I hope that you guys stay up with the technology. Um, with these different machines, I can do my own PCB boards. I can implement my own aluminum cutting. I can implement my own steel cutting. Right now, just in my one car garage, standard size one car garage, I have three CNC routers, a CNC lathe, two 3D printers, um, uh, one, two, three, three about to be four diode lasers. Um, and then I have all of my uh, hand woodworking stuff, like my chop saw, my planer, my joiner, stuff like that. Um, and then as I build up, I'm going to pour another pad out on my side yard, and I'm going to put my plasma cutter up and my air compressor and stuff. So as we start progressing, I want more and more of my CNC machines to be up and running. And that's what I find fun. I used to love building cars, used to love building bikes. Now I love building the machines that make those parts. So as you do it, just keep progressing your skills, and understand that you don't have to have a huge factory to start doing this stuff. Um, you know, it is what it is. So with that being said, guys, I'm going to do a quick cleanup, and then I'm going to uh, find myself on a plane. I'm going to sleep a lot, and be uh, I hope to be seeing you guys tomorrow if I have a good enough connection. All right, all right, guys. Peace.